Alright, hi everyone, and welcome to the first lab. So in this lab, we are actually going to apply what we learned in the first lecture to build our own pneumonia classification model. So the challenge here is to build an algorithm that automatically identifies whether a patient is suffering from pneumonia or not by looking at chest x-ray images. And this is essentially a binary classification task. But by the end of this lab, you should be able to extend the model to include other classes as well, like COVID-19. So before we jump into the code, I want to introduce you to some concepts like the image data generator, which is used for generating batches containing the data. When training your model, sometimes it can be really expensive to load all the training data into the model all at once. So the image data generator helps us to load the training data as batches into the model. The second thing it helps us with is it helps us to apply random transformation to the data. So we could, for example, flip the data, we could zoom into it, we could rotate it. And this helps us to introduce diversity and also increase the training data size. So one of the most important things when you are training your model is to always establish a baseline model. So the baseline model serves as a point of reference that you can actually compare with more robust models you build in the future. The second point is that baseline models are less likely to overfit. So it helps us to get a general overview of what the task will be about and whether it will be feasible. So this is an example baseline model we'll be looking at. We have two convolution followed by max pooling layers. We add our flattened layer, then we finally add our dense layers. So this is what it looks like. We have our convolution layer, our pooling layer, another convolution layer, and then the pooling layer. Then we add on top our dense layers. Now, to improve upon the baseline model, you can actually change the network topology. You can increase the size of the layers. You can increase the depths of the neurons, for example. You could add regularization like dropout. You could change the learning rate. You could also change the batches and then the epochs. So with our task, this is what our directory structure looks like. We have three directories: the training data set or directory, the test data set, and then the validation data set. And all of them contain two directories, which is normal or pneumonia. And each directory that is normal or pneumonia contains images of the respective classes. So moving to our code editor, this is what our training data actually looks like. We have three directories: test, train, validation. And then the test contains two directories: normal, pneumonia, which contains all normal images. We have the pneumonia directory as well. Then the same thing for the train and then the validation. Now, the main reason behind these three directories is that they help us to measure the performance of our model. The training data set is actually what is used to train the model. The test data set is what is used to test the model after we've trained the model. And the validation data set helps us to fine-tune the model. So moving back into the code editor, we want to build our model. And the first thing we want to do is to import all the necessary libraries. So we're going to import TensorFlow, the layers, sequential, the dense, the max pooling layer, and then the image data generator. The next thing we're going to do is to specify the main dataset path, which is specified here. Next, you're going to specify the path to the train directory, the validation directory, and then the test directory. Next, you're going to rescale all our images and then transform them or augment them. And so we can rotate them, we can shift the width, the height, the zoom, the shear range, or we can flip them. Next, we rescale the test data set as well. Now, the reason why we don't actually apply augmentation to the test data set is that we only wanted to introduce diversity into the training data set and not the test data set. So it isn't really important to actually implement the same thing with the test data set. Now, the next thing we're going to do is to flow the training images in batches of 20 using the train data generator like we specified here. And so For every 20 batch, we'll feed it into the model and then train with it. Then we specify the target size or the input size, and in the class mode specifies the task we are doing, which is binary classification. And the same thing for the validation as well. Next, we're going to build our baseline model. So with our baseline model, we have the sequential model followed by the convolution, which has the input shape, the activation layer, the kernel size, and then the max pooling layer. And then we repeat that a couple of times. And finally, we'll add our dense layers on top of it. Now we can go ahead and then visualize what our model looks like. Once that's done, we can actually compile our model with the loss, optimizer, and then the metrics we'll be monitoring. Finally, we can go ahead and then train our model. Now, I want to introduce you to the concept of transfer learning, which helps us to reuse the weight of a pre-trained model for our own task. So as you can see here, we're going to be using the weight of the ImageNet dataset to train our own task, which is the pneumonia classification task. So the first thing we need to do is to cut off the dense layer from the ImageNet and then add our own dense layer on top of it and then train with it or fine-tune the model. So going back into the model, we're just going to use the ImageNet weight that was trained on the ImageNet dataset. Now we're going to specify the input shape, which is 128 by 128, and then we're going to specify include top as false. This is because we don't want their dense layer. Instead, we want to add our own dense layer for the classification. And then we're going to specify the weight, which is the ImageNet. Next, we want to freeze all the layers. This is because we don't want to train the model from scratch. And so, like you saw in the slide, we want to freeze all these layers which have learned the essential features that we need. And then we can add that model on top of our original model and then train with it. Now we can view or visualize what our model will look like. Go ahead and then compile our model, then finally train the model. So that's all you need to know about transfer learning and building your own classification task. In your project, we expect you to build a multi-class classification task. In the next lecture, we'll be looking at time series and text. Thank you so much for joining us.